Hi there, welcome back to the formulaic approach. Now in this video, we are going to be talking about measurement. Um, you see, measurement is basically what we do in physics, okay? In fact, measurement is so fundamental to physics that Lord Kelvin said if you understand an idea and you are unable to measure it, it is not numerically measurable, you probably don't understand it as much. That's just a summary of what he said. Okay, so and what do we measure generally in physics? We measure quantities. We use units to identify the quantities that we measure. Is that clear? Now, when you measure quantities, your precision level is a measure of how close you are to accuracy. Exactly. Your precision is the measure of how accurate you are in your measurement. Exactly. And this idea brings about what we call approximation. Okay? When someone, when two scientists measure a quantity, for example, and the first, let's say they measure displacement, and the first person said, I measured 2.001 meter, and the other person said, I measured 2.01 meter. In fact, if it were even the same, what looks like the same thing, who is more precise? Actually, in maths, you were taught that this is insignificant, right? All right. You see, in physics, the third decimal place that is here shows us that he is more precise than this person. His level of precision is higher because his level of precision is to the third decimal place. But this person's level of precision is to the second decimal place. Exactly. Do you know why this person is more precise than this person? It is because this person tells us that the number here, the number next here is not, maybe there is no number there, or the number is, in fact, it's practically even saying that there is no number there. While this person is telling us that the number ahead of here can be rounded down to 0. It's not significant enough to round up to 1. Is that clear? All right. So he's more precise. So approximation also has degree. Do you understand here? That is, approximation also measures your degree of precision. Do you understand now? So when you measure, you can you can have uncertainties. You can have what is called what? Uncertainties. So uncertainties are basically what? Errors. Your uncertainties are what? Your errors. And there are two major types of error, or errors are classified into two. We have the random error and the systematic error. Systematic errors. Random errors might come from different, random error simply means errors from any source. Exactly. But systematic error is the one that is, I think systematic error is divided into maybe four. So I know there is instrumental error. Instrumental error is error due to faulty instrument. Exactly. There's also a zero error. This is also instrumental error is error due to maybe wrong, improper calibration of your ruler, for example. But zero error is this. Look at a scale that you use in measuring your weight. You know when you get off that weight, that arrow will go back to where? 0, isn't it? But if your own has maybe slacked or has a problem that it doesn't come back to 0 again, maybe now when it goes back, it now stays at 1, for example, that is a 0 error. It means that there will be inconsistency in his measurement. Is that clear? All right, because it has a fault. Another one is personal error. That one is error due to your own inaccuracy. Yes or no? Personal error. Someone that is long-sighted may not be able to measure things that are too close. Do you understand? Personal error. All right, those are just errors. There is now something called compound error. Compound error is just stemming from all of this still. Compound error is actually error that compounds. What do you mean by compound? Error that adds up in another step. So if you make a mistake in, for example, look at this. What's formula for area? Length times breadth. If you are calculating the length, and the length was 2.01, and you calculated 2.03, you know you have made an error in the length. If the breadth was 1.440 or 45, for example, and you calculated 1.44, did you see that your error from here times error from here will compound into a bigger error? That's what we mean by compound error. So the error in your area will be error from this and error from this. If you are confused, raise your hand. All right, good. That's what compound error is. I'm going to show you the two ideas. There are more than two, okay, but I'll just show you two that I remember. That is addition and subtraction. Addition and subtraction. So with equations that have to do with addition and subtraction, this is the kind of error we could make. If the actual size of something is x, or no, let's use m, and that m comes from a particular x plus y. If you commit small error in this x, the small error you commit, instead of measuring 2, you measure 2.1. It means that your x is no longer x is now plus a small value dx. We use dx to represent small x, that is small addition to x. Then plus this guy, you committed small error in measuring y, it will be y plus dy. It means that what you'll be calculating, the answer you'll get will be m plus what? dm. Where dm will be equal to what? The two errors that you committed here, dx and dy. Is it clear now? But your error may not be, we cannot say whether your error is exactly something you added more or added less. I don't know if you understand what I'm trying to say. You know, you can commit error if your actual value is 2 and you did 2.0 at 2.1. You know, you committed an error of 0.1. But another person, an error of plus 0.1, that's your own error. If another person measures 1.99, that person committed error of what? 0.01. Do you understand now? But this time minus 0.01. Do you see it now? So your error may be plus or minus. So for that reason, dm, therefore, that little value that has been added to the original actual length is now equal to, or actual value, magnitude of the guy, is now plus or minus dx plus dy. Is it clear? A type of question that might come from that is this. Look at the size of a pipe. The diameter of a pipe. I'm showing you a pipe now like this. You are now seeing this. Is that clear? So this pipe has a thickness. This is the thickness of the pipe. This is the inside of the pipe, right? If you measure from here to here, so let's say the inner diameter was measured to be 2.2 plus or minus 0.01 meters. Exactly. And outer diameter measured to be 2.4 plus or minus 0.1. Or let's use 0.02 this time, meters. And that's very big. You know what meter is, right? Let's use centimeters. try to be just how I mean now. Even though this one is larger than centimeter. You know centimeter scale, right? So this is like 2 centimeters here. All right. So what is your percentage error? What if you are asked to calculate the percentage error? All you need to do is first, what's the error in the calculation? The erroneous calculation. The erroneous calculation is 0. The erroneous calculation first will be this m plus dm. Exactly. So the erroneous calculation, which will be the diameter, the thickness. Calculate thickness. Calculate thickness. That's what you'll be asked to do. Calculate the thickness of this pipe. What do? Are you adding or subtracting? Subtracting, right? Because this is inner diameter, outer diameter. So you subtract inner from outer, you get this, right? Is that one clear? Yes, sir. All right, so that's subtracting 2.4 plus or minus 0.02 minus 2 plus or minus 0.01. Is that clear? That is the thickness. Let's call it C. So C therefore will be 2.4 minus 2 plus or minus, according to the answer to the listing, plus or minus what? This small 0.02 plus 0.01. Is that clear? So T therefore becomes this minus this 0.4 plus or minus 0.03. This is the erroneous calculation. Is that clear? What if you are now asked to calculate percentage error? Percentage error is just, what's the error? The actual error over the error rather over the actual value. You know this is the actual value. 0.4 times 100. Exactly. Then you do your maths. %7.5%. That's the answer. Is it clear? All right. Now, let me do the one for addition and subtraction, and that will be it. Then we'll go to dimension analysis. For product and quotient now. That is, give me a formula in physics that has to do with multiplication. Area, length times breadth, or volume, thank you. Length times breadth times height. Now, if you commit a small error dl in this one and a small error db in this one, it will compound to dA. Is that clear? So dA, therefore, the formula for dA is actually this. The ratio of this to the original length plus or minus dl over L plus dB over B. Is it clear? If it's your volume, volume is length times breadth times height. So our dV, if we make the error dV that will be there, will be equal to what? Plus or minus dl over L plus dB over B plus dH over, God bless you. And that's it. So all you just need to do is divide, if I give you length to be 2.01, just do 0.1 over 2 plus this is exactly. So your volume, your erroneous volume will now be volume plus dV. Is that clear? All right. So that's how to, okay, that one is product. What about quotient? Give me a formula that has to do with quotient. Density, right? Pressure. Density, mass over volume. Is that clear? So density is, yes, thank you. If there is a small error dm in mass, the d, that is the little mistake in the error in density is going to be plus or minus dm over the actual mass plus dv over the actual volume. So meaning that, listen now, if you are given mass of 2.02 plus 0.1, 2 plus or minus 0.1 kg, and you are given volume of 0.5 plus or minus 0.05 kg, for example. To get the volume, the density is going to be equal to 2 over 0.5 plus, is it clear now? But it's not plus, it's plus or minus, right? Plus or minus, what is dm? 0.1 over 2 plus 0.5 0.05 over 0.5. Do you understand now? So the answer you get here, plus or minus that will be your actual error in volume. If I now ask to calculate percentage error again, the answer you get, that plus or minus error over the guy times 100. Is it clear? All right, let's go to dimension analysis now. Please check, is it still? Sure, okay. You will come without a sound. Matthew, you help me get my marker. Thieves came in the middle of the night and stole it. All right, let's go. All right, let's do dimension analysis now. Analysis of dimension, we always break down quantities to the fundamental quantity. So it means you need to know fundamental and derived quantities, right? Every other quantity, how many fundamental quantities do we have? 7. How many fundamental quantities do we have? They are what? Mass, length, time, temperature, luminous intensity, electric current, amount of substance. What's the unit of mass? Kilogram. Current. What's the unit of mass? Kilogram. What's the unit of length? Meter. What's the unit of time? What's the unit of temperature? Kelvin. Lord Kelvin. You just heard me mention his name just now. Current. Ampere. Luminous intensity. I did not write luminous intensity and amount of moles because for most analysis of dimension analysis, we don't touch those ones usually. Is that clear? All right. Most quantities that we analyze, we don't need those ones. These are the 5 that we need. Is it clear? Yes, sir. Let's start with the basic and simplest one. Number 1 is area. What's formula for area? Look here, the idea. No, before we start this, let me teach you something first. What is 2 over 3 over 4? What does this mean? This means 2 divided by 3 over 4. This means that you are using a fraction to divide a whole number. Whenever you use a fraction to divide a whole number, this is what you get. This becomes 2 times 2 over 1 times 4 over 3. You remember, right? So what does that mean is that whenever you use a fraction to divide a whole number, the denominator of the fraction will come up. 2 times 4 over 3. Do you see it? This is different from 2 over 3 divided by 4. This is now a whole number dividing a fraction. Is it clear? In this case, this guy will come down. Let me show you. 2 over 3 divided by 4 over 1. 2 over 3 times 1 over 4. Do you see it? This denominator will come down. It becomes 2 over 3 times. Is it clear? All right. Did you get this manipulation? It will help you to be fast when we get to the thing. Because I will rush it all. So make sure you are listening. It's only this first one I will explain calmly. Okay, no. Another tool you need is 1 over a. Do you know it can be expressed as a raised by minus 1. 1 over a squared will be a cube what? A raised by good. Since you know this, we are good to go. Now listen. These are your 5 fundamental quantities. Is that clear? There are 7 fundamental quantities, right? But these are the 5 that we need for the analysis. Now, you have to come and compare. Is that clear? Length. Is length part of this? Of your fundamental? Is there, right? Now, breadth corresponds to which one here? Length again. Breadth is a type of, other types of length are height, distance, radius. Is that clear? All right. So this becomes what? L squared. Is that clear? What will be the basic unit? The basic unit is what? Meter squared. What's the unit of length? Meter. So the basic unit will be what? Meter now squared. Is that clear? Second quantity, let's do volume. What's the formula for volume? Length times breadth times height. Length corresponds to what? Length. Breadth corresponds to what? Height corresponds to what? Don't know music. This becomes L cubed. And basic unit to be what? Meter cubed. Let's do another simple one. Density. These are the only mass over volume. Mass corresponds to what? Mass. Make sense? Volume is already what? L cubed. You see it? Length times length times length. Exactly. So you say density is equal to m over L cubed. This becomes m. L will come up. L is power minus 3. Whenever something comes up from under like that, it will carry negative power. Alright. Let's now go to good questions. Is that clear? Good questions. Let's do this one together. Look at this formula. Let's do Young's modulus together, or coefficient of elasticity. Coefficient of elasticity. What's the formula? FL over AE. Where F is what? Force. Where L is what? Length. Where A is what? Area. Where E is what? Extension. Is that clear? Now what is force? Force is mass times acceleration times length. Is that clear? All over area, all over length times breadth. God bless you. Then times, what is extension going to correspond to? Length. Extension also means length. Extension means how long something is. Is that anybody's father? The person honking. Okay. L. So mass corresponds to mass. So it will be m times, what is acceleration? Velocity over, so velocity over t times L. All over L times L times L. Is it making sense? L can cut. This becomes m times, what's velocity? Distance over time. And distance is length. Displacement actually, right? Speed is distance. God bless you. So the velocity is displacement, which is L over t. But then again over t. God bless you. Then over L squared. Make sense? This becomes m. I told you when you are dividing a fraction by a whole number, this guy will come down. It becomes m over t squared all over L squared. Is it making sense? I told you when you are dividing a fraction by a whole number, this guy will come down again, right? So it becomes m L over t squared dot L squared. One L goes from here, remains one, right? It becomes m over LT squared. Our answer becomes m L raised to power minus 1, t raised to power minus 2. Is it clear? I'll solve one last one, and I'll give you an assignment. Let me solve capacitance. What is that? Where is it? Now, the formula for capacitance is Q per V. Quantity of charge stored per volume. Has she found him? Okay. Quantity of charge stored per volume. And remember that quantity of charge, see, current is time rate of flow of charge, right? So it means that quantity of charge will be what? Current times time. So here, capacitance becomes current times time over voltage. Q is charge. This one is voltage. Now, We have to find a formula for voltage as well. Now you see voltage. What's the formula for work done? Let me explain what voltage is first. Voltage is the work done in bringing a point charge from one point to another. Is that clear? So what's the formula for, so since it's work done, we call it work done per unit. Voltage is work done per unit charge brought from infinity to a particular point or any point to another. For example, your battery, it will be the work done in bringing a charge from here to this place. You know that's what you are doing. If you connect wires to a battery, basically, charges begin to flow from here to the other. You understand now? And that's what we call current. So now here's my point. What's the formula for work done? Force times, God bless you, over Q. Now, you see, force, yes? This Q, yes, is still current times time, yes. But this F is not just any F. It is electric force. Electric force is actually electric field intensity or strength times the quantity of charge put in that field. I've seen it before. Good. Then times D. You must have been taught electric charge, right? Conductors, non-conductors. Okay. Distance is now L over Q. So Q can cancel from here. E is, we don't have, what is the dimension for E now? E is electric field intensity. Maybe that's not what we're supposed to do. Maybe what we're supposed to do is express, yes. V is now ER, right? V is now ER. Now, EL actually, EL. R is radius, but L in this case. So E, we need a value for a unit, a basic unit for E. And I don't think there is any basic unit except we bring it back to F per Q. Make sense? Or F per IT times L. You agree now, right? So V equal to this. So since we brought it back to this, then we can therefore say that C is now IT over V, right? And V is FL over IT. Remember, what this one do? So C equal to what? IT all squared. IT times IT now. You agree? Over FL. Now, so I is there, I squared T squared over, what is force? MLT squared, that's force. This force here. You agree, right? So ML per T squared times L. This becomes I squared T squared. Let's re-express it. It becomes ML squared over T squared. Whenever I divide the whole number by a fraction, what will happen? This one will go up. Do you remember? So this becomes I squared T squared times T squared over ML squared. This becomes I squared T to the fourth over M raised to power 2. So our answer is M raised to power minus 1, L raised to power minus 2, T raised to power 4, I raised to power 2. That's the answer. And the basic unit, if you want to write it in basic unit too, M is what? Kg. So we have per kg per meter squared. Second raised to power 4 ampere unit of current squared. Is it clear? Alright, so I'll show you other questions later, how to solve other questions. See you in the next video. God bless you.